Hello again, everyone, and good morning. We're in week 8, if you can believe that. We only have one more marking period, and then we're going to be done. So let's take a look here. Make sure you're doing your bell work accordingly. It looks like retest sign up is on the wall. Make sure you put Chapter 7 or Chapter 8. Chapter 8 is the one we just took, so I still have to work on it a little bit. You should have it back by Thursday, I'm sure. So they'll give you till Friday to sign up. So make sure you sign up by Friday. Also, detentions. If your name is still on this list, you owe me a detention, okay? So make sure that you come 1 minute before lunch. Just come in, sit down for 1 minute, and I'll let you go. All right, rationalize a denominator. Let's take a look at that one. Well, remember, you cannot have a fraction in the denominator, and here you do. So in this particular case, you're going to do a radical in the denominator. So you're going to put the square root of 5 over the square root of 5. This gives you 2 5s, so that's going to be the square root of 25. So it's going to be 2 square root of 25 over the square root of 25. And not quite sure. Let me back up and let me rethink this. This top part is going to be 2 square root of 5 over the square root of 25. Okay, now I'm on the right track. This square root of 25 is perfect, so your final answer will be 2 square root of 5 over 5. You cannot reduce this 5 and this 5 because one's inside the radical and one is outside. Next one. On this one right here, what we're going to do is we only want to get rid of that square root of 7, so put the square root of 7 over the square root of 7, so that's going to be the square root of 21. So 2 square root of 21 over 5 square root of 49. The square root of 49 is 7, so that's going to be 5 times 7. So it's going to be 2 square root of 21 over 35. And that's how you rationalize the denominator. Make sure you know that. Make sure you're still working on Carnegie. And by the way, we're starting on a new 2-week period of Carnegie, so it starts today. Make sure you know that. And this one right here is a review question for the EOC. I lost my focus. Give me a second. Typical Monday. All right, so draw that diagram. Now you had one like this on the EOC and some of you missed it. Well, look here, PC. There's a name for this one right here, centroid, circumcenter, or I think it's a centroid, okay? You might want to look that up. Anyway, so PC is from here to here, and that equals 24, and that's given. Okay, that's the reason. In any event, remember it's 1/3 and 2/3, so this one is 1/3 and this one is 2/3 of the whole thing. So you would take 1/3 times 24 over 1. Well, 3 goes into 3 once, 3 goes into 21 7, so the answer here is 7. And then this one's twice as big, so that's 14. Or you could do 2/3 of 24 over 1. 3 goes into 3 once, 3 goes into that 7. 7 times 2 is 14. 14 plus 7 is 21. Actually, let me think about that. 24, that's 14. And 3, 7, and that's adding up to 21, not 24. So let me rethink this. The whole thing is 24. Oh, it should have been 8. Okay, sorry. 3 goes into 21 8 times. My fault. And 8 times 2 is 16, so that should be 16. Okay, and this should be 8. 3 times 8 is 24, and 8 times 2 is 16. Okay. Well, it's a Monday, but there it is. Okay, so just remember 1/3 and 2/3. All right, let's get off of that. Let's talk about today's worksheet. Now, if you can't be with us, here's the answer key. And you can pause it, you can copy it, you can go online and find some other videos if you want to, okay? There are 3 more trig functions that I need to talk to you about, and they're right here, and I want you to copy them down. So let me go ahead and find that where I have it. Okay, here it is right here. So copy down these trig functions right here, and these are the ones that we're going to talk about today. Okay? All right, so really they're just inverses of each other. Put this away. All right, let's work some of these. This says the secant. Well, if you look at your formula sheet, secant is the opposite of cosine. So cosine is CAH, remember so, ka, toa, okay? And so secant, you're going to flip this. So the secant is going to be h over a. So it's going to be h over a. So it's going to be the hypotenuse. So you're standing here, you can change that to an x. So it's going to be the hypotenuse over the adjacent. That's your hypotenuse. This is the adjacent. So it's going to be 17 over 15. And that should be the answer. And that, in fact, is the answer. So if you use the formula sheet, you should be able to do it. Let's try one more. Cosecant, if you look here, cosecant is the opposite of the sine. Okay? So sine was OH. So if you're standing here, it would be opposite over hypotenuse, which is this one. So it'd be 16 square root of 2 over 24. But the cosecant is the inverse of that, so it's going to be 24 over 16 square root of 2. We're going to reduce this. 8 goes into that. 8 goes into 16 2 times. 8 goes into that 3 times. So it should be 3 over 2 square root of 2. Let's check that one to make sure that's right. And let me think about this here. Number 5. Number 5, they have 3 square root of 2 over 4. So let me rethink that. All right, let's back up. So the formula here is the opposite of the sine. And sine is opposite over hypotenuse. So that's 16 square root of 2 over 24. So you're going to switch that up. Oh, I see what's wrong with it. You had to rationalize the denominator. So here you got to do the square root of 2 twice. Okay, my fault. So it's going to be 3 square root of 2 over 2 square root of 4. But the square root of 4 is 2, remember? So 2 times 2 is 4. So it's going to be 3 square root of 2 over 4. So you're going to have to rationalize your denominator on some of these. And there's the answer. Okay, so that one was right. I just didn't finish it. And that's how you work these problems, okay? So again, you got to refer to these right here. All right, that's it. Have a good morning.